right, this is the last type of KSP question in Unit 3. So this is type 4. So this one is called the maximum ion concentration problems. So our goal for these is going to be to determine the maximum concentration of one ion that can exist in a solution without forming a precipitate. So remember, the concept here is that KSP limits your product of ion concentrations. So an example of a question could be, for silver chloride that has a KSP of 1.8 times 10 to the negative 10, that means that the product of silver times chloride can only be up to 1.8 times 10 to the negative 10 before a precipitant will form. So if I wanted to find the maximum chloride ion concentration when the silver concentration is 3.2 times 10 to the negative 5, I could say that chloride would equal KSP divided by the concentration of silver. So this is just a rearrangement of this equation here. So I know that the KSP is 1.8 times 10 to the negative 10. I know that the concentration of silver is 3.2 times 10 to the negative 5. So I could find the maximum ion concentration of chloride, which would be 5.6 times 10 to the negative 6. Which means if the concentration of chloride ions added was less than 5.6 times 10 to the negative 6, the solution is unsaturated and a precipitate will not form. If the value of chloride ions is 8.5 times 10 to the negative 12, the solution is saturated but is at its verge of precipitating, right? If you added the chloride ion concentration more than 5.6 times 10 to the negative 6, then a precipitate will form. Precipitate. And I should probably put concentration M in here. Go back and do that. Right? So let's practice some of these. Let's calculate the maximum possible concentration of iodine ions in a solution where the silver concentration is 1.0 times 10 to the negative 5. So the first thing we want to look at is silver iodide as a dissociation. So silver iodide dissociates into silver ions and iodine ions in a 1-to-1 ratio. The KSP expression would be silver times iodine. We want to find the maximum concentration of iodine ions. So I'm going to rearrange this equation to solve for iodine, which is going to be KSP divided by the concentration of silver ions. So then I'm just going to go to my data package and look up the KSP for silver iodide. I'm going to go down a page. It's funny, we have not duplicated yet. I've been keeping this page open the whole time and I've only put arrows in different things. So silver iodide has a KSP of 8.5 times 10 to the negative 17. It cannot hold a lot. That is very low solubility. And then they're telling me that the concentration of silver is 1.0 times 10 to the negative 5. So the maximum concentration of iodine ions is 8.5 times 10 to the negative 17 divided by 1 times 10 to the negative 5, which gives me 8.5 times 10 to the negative 12 moles per liter, or molar. So that's the maximum concentration of iodine ions that could be added before a precipitant is formed. All right, how do you feel about that? Hopefully this is kind of like ending on a nice note. Sometimes things get harder and harder. I feel like this is definitely easier than type 3. All right, give this one a go. Pause the video. What is the maximum possible chloride ion concentration that can be dissolved in 1.0 times 10 to the negative 3 solution of lead iodide without precipitating lead chloride? There's a twist. So lead chloride would form lead ions and 2 chloride ions. Okay. We want to know the maximum concentration of chloride ions dissolved in a 1.0 times 10 to the negative 3 solution of lead nitrate. So the only thing you're kind of tested on here is that if lead nitrate is bringing the lead ions, what would be the concentration of lead? Well, because it's a 1-to-1 ratio, then the concentration of lead ions is also 1.0 times 10 to the negative 3. But that's definitely something that could be played with, right? So we're going to say the concentration of lead ions in solution is 1.0 times 10 to the negative 3. And we're going to set up KSP. KSP is equal to lead times chloride squared. We want to find the maximum concentration of chloride, so I'm going to rearrange this formula, but I'm not going to put square root. So I'm going to put chloride ions squared is equal to KSP divided by the concentration of lead. So I'm going to look up the KSP. So lead chloride, again, a new one. So lead chloride is 1.2 times 10 to the negative 5. And then the concentration of lead, we said, was 1.0 times 10 to the negative 3. So then the maximum ion concentration of chloride would be the square root of what answer I get here, right? So don't forget that. So we're going to do 1.2 times 10 to the negative 5 divided by 1 times 10 to the negative 3. And then I'm going to take the square root of that answer. And I get 0.11 moles per liter. Done. The next lesson, if it makes you feel better, is very short.